All right, so welcome back to Inorganic Tutor YouTube channel. This particular function, we want to look at how we can differentiate this particular function on the board, right? And this particular function is an exponential function, but it has an exponent of root of x, right? So let's look at how we can deal with this particular function. Guess what we are going to do in here to get to our final solution, right? So here we have dy dx equals, right? So wait, let's do this first. What do you have to do? First, we need to introduce what we call the natural log, which is the ln, right? ln. So introduce what we call the natural log. Introduce the natural log, the ln, right, on both sides. So we have ln y is equal to ln 5 power root x, right? If you don't do this, you can't arrive on your right solution. So here, we can now go ahead and do what we call, let's apply what we call the logarithm law, right? First, we all know that when you have log a power b is the same as b log a, right? So if that is true, if this property is true, then we can use that here and then bring this power back here. So we have ln y equals root x ln 5, right? So here, now we have two functions multiplying, so we can use the product rule, right? And then we have ln y here too, so we can use the chain rule on this particular one, right? We all know that when you have ln and you want to differentiate, you take 1 over the inner function, right? The inner function, take 1 over 8 times the differential of the inner function, right? So we have y prime, right? And that should be equal to, when we differentiate this, right? We have to differentiate this, right? So for us to make the work so simple, let's change this particular root x to x power half, right? So we have y prime over y, and that should be equal to, let's differentiate this. When you differentiate this, you are going to have half x power minus half. Brought this down, subtract 1 from this, and you have minus half. Then we maintain the second function plus, because we are following what we call the product rule, plus differentiate this, right? You know this is a constant. So when you differentiate it, we have 0. And then we maintain this, which is x power half, right? Of course, this is going to be y prime over y, and that should be equal to half x power minus half ln 5 plus, this is of course 0 here, so we have this. Let's go ahead there and then simplify. So we have y prime over y should be equal to half x power minus half ln 5, right? And our basic computations, we know that x power minus half is the same as 1 over x power half, right? So we can bring this thing down. So we have y prime over y should be equal to half times 1 over x power half ln 5, right? So here we can have y prime over y should be equal to ln 5, right? This multiplying the whole of this, we have 1 times ln 5, and that is ln 5 all over 2 x power half, right? And we know that this is, of course, a root. So we can have ln 5 over 2 root x, right? But we are looking for the differential of the function, not differential of the function over y. So we cross multiply and we have y prime is equal to ln 5 over 2 root of x, all multiplied by y, right? But from the question, we were given the value of y, which is of course this here. So we substitute the y into this. So we have y, our y is of course here. So we put the y inside, and that is equal to ln 5 over 2 root x multiplied by the y, which is 5 power root x. And that's it. So let me write the final answer at the top here for you. So we have y prime is equal to ln 5 all over 2 root x multiplied by 5 power root x. And this becomes our final answer to this particular question. Y equals 5 power root x. Ladies and gentlemen, we have been able to arrive in the right solution. So thank you very much for watching. Keep on watching. I'll give you more content as well. Bye.